Okay, so today we're going to use everything we've learned so far in this unit to start solving trig equations. And we're going to think about this in a new context. So we're not going to think about the limitations that we learned for the inverse sine and inverse cosine and inverse tangent functions, where we only can choose angles between negative pi over 2 and pi over 2 or 0 to pi. We're going to think about all the possible solutions for a given trig equation. So if we think about that, for cosine of x equals 1/2, we would look on our unit circle and figure out where are the cosine values or the x values 1/2. And so we would see that that happens when x equals pi over 3. It also happens when x equals 5 pi over 3. Happens when x equals negative pi over 3. And it's going to happen an infinite number of times because we can infinitely rotate around this unit circle. So we need kind of an easier way to write the solutions. So the best practice for this is to we'll take the first two solutions that we found between 0 and 2 pi. So I'll take the pi over 3 and the 5 pi over 3. And then to each of those, I'm going to add the coterminal angle. So that would happen at one more revolution. So we'll say plus or minus 2 pi n. And that n is just an integer, a whole number, and it indicates a revolution. So if n was 1, we'd be adding 1 revolution. If n was 2, we'd be adding 2 revolutions. But what this indicates is, if you think about how it looks on the graph crosses the x-axis an infinite number of times, and this just identifies all those times that happens. So this is how we write our solutions for all the possible angles. We may sometimes have a restriction that says we just want to see on the interval from 0 to 2 pi. These were on the interval from negative infinity to infinity. So that's for these. If we just want the interval between 0 and 2 pi, and notice how I've included 0 but excluded 2 pi, that gets us all our angles in one revolution. And so those would just simply be pi over 3 and 5 pi over 3. So just the two that we listed without the plus or minus 2 pi n. So just pay attention to how you're being asked to provide your answers. If you're asked to provide without any limitations, then you add or subtract a revolution. If you're asked to find them only on the interval from 0 to 2 pi, then you just list the ones that are between 0 and 2 pi only. No negative angles, no plus or minus a revolution. So let's think about this now for our next problem, sine of x equals 1. So now we're looking on our unit circle and saying, okay, where does the y value equal 1? So that happens only in one place. That happens up at pi over 2. If we want to identify all the possible solutions, that would be pi over 2, and then we could say, and any coterminal angle. The way that we indicate that is like we just talked about. We take that pi over 2 and then plus or minus 2 pi n. If we want to limit it on the interval from 0 to 2 pi, then we just say x equals pi over 2. So just pay attention to that distinction. Okay, so now we're going to move on to thinking about how do we actually solve a trig equation. So when you solve any type of equation in algebra or geometry, you're trying to isolate the variable. Our goal here is to isolate the trig function. And so all we're going to do is use our basic algebra skills to do that. So if we say solve, and I give you, let's say number 1 would be 2 cosine of x equals 1. It's a good idea to identify what the trig function is. The trig function here is the cosine of x. And so we're going to go ahead and isolate that. And the way that we get that done is we divide by 2. Now cosine of x equals 1/2. And then we can look and figure out where are the angles where that happens. Now notice with the instructions it says solve. It doesn't have any restriction on the interval. So we're going to list all the angles and those revolutions. And so this is just like the first example we did. Where does the cosine value equal 1/2? Well, it equals 1/2 at pi over 3 and at 5 pi over 3, and then every revolution after that. So we do plus or minus 2 pi n. Let's try another one. So this one is going to start off like this. Sine of x plus the square root of 2 equals negative sine of x. So we just have to be real careful with our algebra on a problem like this. So I see a sine x on two sides of the equation. So what I need to do, just like I would do if these were x's, we'd want to get our like terms on the same side of the equation. So I'm going to take the sine of x that's on the left, and I'm going to subtract it. So that gets rid of what's on the left here, and we just have square root of 2 equals. And then a negative sine x take away another sine x makes negative 2 sine x's. All right, we're still trying to isolate that variable, and the thing that's in the way here is that negative 2. And that negative 2 is multiplying times sine of x, so I'm going to divide. And then those cancel. So when I finally isolate it, it says sine of x equals negative root 2 over 2. All right, so that should look pretty familiar. Negative root 2 over 2 is one of our ratios from our unit circle. And so then we go and look and say, all right, where are the y values, since we're talking about sine, where are the y values? Negative root 2 over 2. And I see that happening at 5 pi over 4 and at 7 pi over 4. So I'm going to say x equals 5 pi over 4 and 7 pi over 4. And then if I want to get all those solutions, I have to say plus or minus 2 pi n. Plus or minus 2 pi n. And that gives me all the possible solutions. Okay, so let's try another one. And this time one of our terms is going to be squared. So if I have something like 4 cosecant squared of x minus 1 equals 0. All right, so if you were to think of this just like any other equation, it's like 4x squared minus 1 equals 0. And we want to isolate this cosecant squared. The difference is when we finally get it isolated, we're going to have to do one more thing to simplify or to solve. So I'm going to start by adding 1. 4 cosecant squared of x equals 1. The next thing that we need to get rid of is that 4 that's multiplying times cosecant squared, so we're going to divide. So we can say cosecant squared of x equals 1/4. Now we're not quite done yet because we want to know what the cosecant of x equals. So I'm going to go ahead and square root this. And I'm going to say that the cosecant of x equals plus or minus. Now the square root of 1/4 is the same thing as taking the square root of 1 and the square root of 4 separately. So the square root of 1 is 1 and the square root of 4 is 2. So we're good to go there. All right, so we've solved. However, cosecant is not really one of the functions that we look at on the unit circle, but its reciprocal is. So let's rewrite it as its reciprocal. So if the cosecant of x is plus or minus 1 over 2, then the sine of x is plus or minus 2 over 1, or 2. All right, so what we're supposed to do now is go look on our unit circle and say, okay, where are the y values, positive or negative 2? Now, if you remember from some prior lessons, we talked about this. The biggest and smallest y values anywhere on this unit circle are positive 1 and negative 1. And so this is not a possible sine value on the unit circle. So this is not on the unit circle. So we would say that this is undefined. We do not have a solution. So just be careful for that. We want to make sure the angles we're going to look for actually are on the unit circle. Okay, let's try one more. and see how we do. All right, so for this one, we're going to work finally with tangent. 3 times tangent squared of x minus 3 equals 0. So go ahead and identify what it is we're trying to isolate. So there it is, tangent squared of x. And let's do our algebra. We have to first add this 3 over. So then I get 3. Make that look a little bit better. We get 3 tangent squared of x equals 3. To get rid of this 3 right here, we need to divide both sides by 3. So tangent squared of x equals 1. Still not done yet. The tangent squared of x equals 1, we need to figure out what the tangent of x equals. Now here is where a lot of mistakes tend to happen. When we take the square root of 1, people quickly go, oh great, the square root of 1 is 1. However, when you square root both sides of an equation, don't forget your plus or minus. If you forget your plus or minus, you're going to see how we would end up losing some of our solutions. We would be missing some of our solutions that exist. Okay, so on the unit circle, tangent is y over x. And we want our y over x to equal 1. That means we're looking for where our y and x values are the same. So if you go look at your unit circle, you can see that that happens at every pi over 4 angle. In quadrant 1, it happens at pi over 4. In quadrant 2, it happens at 3 pi over 4. Because if I divide root 2 over 2 by negative root 2 over 2, I get negative 1. So we're going to take all 4 of these angles. So I'm going to say x equals, and since I can write these there's a shortcut way. We know that this happens at pi over 4, and then 3 pi over 4, 5 pi over 4, basically every 90 degrees. We can say plus or minus pi over 2n. And this is kind of a shortcut. So since these happen in regular intervals, we can say x equals pi over 4 plus or minus pi over 2n. If you wanted to do this the long way, you could write each one of these out. Pi over 4 plus or minus 2 pi n. 3 pi over 4 plus or minus 2 pi n. 5 pi over 4 plus or minus 2 pi n. And 7 pi over 4 plus or minus 2 pi n. It's the same thing, but this is a whole lot faster. And this really only works when the solutions are evenly spaced around the unit circle. So it really only works on these pi over 4 angles, typically. So just keep an eye out for that. All right, so this is the same thing as that. It's just written out a long way.